Graphing other functions. So here we're going to look at reciprocal functions. A reciprocal function is one written in the form y equals 1 over f of x. On your CAS, graph y equals x squared minus 9 and y equals 1 over x squared minus 9. And then can you observe the following? When the original function passes through the x-axis, the reciprocal function has an asymptote. As the original function gets larger, the reciprocal gets smaller and vice versa. So I did plot it on my class pad, and here it is. And I actually have a print of that, which I'm going to bring in to here. So the red graph is the 1 over x squared minus 9, and the blue graph is the original x squared minus 9. Note that the graph doesn't just simply stop at these points here. It's just that the dots on the screen get such that we can't draw in the whole asymptote. So the asymptote would actually go off along the asymptote in all of these places. Now, note where the original graph crosses the x-axis. So the original graph crosses at -3 and 3, and that's the asymptote of the reciprocal graph. When the original graph gets larger, so it's going out here and down here, we have small values. Now, when we have the minimum here at -9, the reciprocal graph will take the value -1/9. And then when we have these very big values out here, the 1 divided by that tends to 0. As the reciprocal graph gets larger, the original graph gets smaller. Of course, if you have 1 divided by a positive, that is equal to a positive, and 1 divided by a negative is equal to a negative. That's why when this is -9, this is -1/9, and when these are becoming large and positive, these tend to 0, but they're still above the axis. So, for y equals 1 over f of x, y equals 1 over f of x has vertical asymptotes where y equals f of x has zeros and vice versa. So if this one has a vertical asymptote, this one will have a 0. Y equals 1 over f of x has a relative maximum where y equals f of x has a relative minimum. And that would work the other way round as well. If f of a lies on y equals f of x, then a1 over f of a lies on y equals 1 over f of x. We discussed the 0, -9 and the 0, -1/9. Y equals f of x and y equals 1 over f of x meet on the lines y equals plus or minus 1. And that's because 1 over 1 is equal to 1, and 1 over -1 is equal to -1. And we can see they meet here, and they meet here, and that's on the lines y equals 1 and y equals -1.